All right, number 3 on the Unit 4 review, we're looking for the point of inflection. That is the place where the graph changes from concave up to concave down, or concave down to concave up. All right, so that is going to be the second derivative that we're interested in. And we want to know two things: if the second derivative is equal to 0, and if it changes sign on either side. So it's not enough to just say, oh, it equals 0, because that doesn't necessarily mean that it changes concavity. You have to check on either side of it. Alright, so first things first, let's go ahead and find the first derivative. Y prime equals 3x squared. This looks like it's all power rule. Plus 16x minus 4. Alright, let's do it one more time. Six x plus 16. Alright, so first things first, let's set that equal to 0. We'll subtract 16 from both sides and divide both sides by 6. And we'll end up getting negative 8/3 if we reduce. Okay. So now let's do our little sign chart. Alright, we know at negative 8/3 the function is, the second derivative is 0. And we want before negative 8/3. Good Lord, this is, and after negative 8/3. Alright, so let's pick a number below negative 8/3. Alright, so if you're not really sure how much negative 8/3 is, then just pick a really negative number. But negative 8/3 is a little bit less than 3, so let's go with negative 5. Alright, if I plug in negative 5 for x into my second derivative, 6 times negative 5, negative 30 plus 16, that gives me a negative answer. And if I pick a number above negative 8/3, let's just say 1. 6 times 1 plus 16 gives me a positive answer. So there is a point of inflection at x equals negative 8/3 because the second derivative changes sign at this point. So you'd want to word it something like that. So we'll say x equals negative 8/3 is a point of inflection because y double prime and the second derivative changes sign at this point. Alright, it's really important that you